Hey, you crazy guys, how's it going? This is Coach Scott. Hey, let's get into more about chemical reactions. So, we're going to talk about synthesis and decomposition reactions. And most of you know what synthesis is, and these are the different types of reactions we're going to be studying. All right? Because we know chemical change takes place in a reaction, and we can classify them in a couple of different ways. Now, we're going to use this method this year. All right? We're going to talk about five types of reactions. We're going to talk about synthesis. Another name for that would be combination. All right, where we combine two different chemicals into another new chemical. Decomposition, which is where we take one apart. Combustion, which is where we burn something in oxygen, or hydrocarbon and oxygen. Single replacement, double replacement. Now, AP Chem, IB Chem, all right, college chemistry, you're going to be talking about some other classifications. The acid-base reactions, okay, and the redox reaction, or the oxidation reduction, and we'll mention that some for some of you guys. Then, of course, a precipitation reaction, which is pretty much a special type of double replacement. So, they're related. Okay, synthesis, decomposition, and single replacement reactions are special cases of redox reactions where one is reduced and one is oxidized. We'll talk about that later. Then an acid-base and a precipitation reaction are double replacement types of reactions. And we will cover precipitation reactions, and we'll touch on acid-base reactions in this unit. Okay. We'll talk more about redox later on for some of you guys. So, we're going to use this classification systems, and we're going to start with synthesis and the decomposition reaction. So, when two or more substances combine to form a new compound, we call that a synthesis reaction. So, compound A, substance B come together and they form AB compound. All right. Now, usually the product is a binary compound, which is two elements. All right. Now, there's other cases like photosynthesis, you might remember from biology, where you've got multiple elements that combine and they'll form multiple products, one of which is more complex than either reactant. Now, in all cases of synthesis reactions, one of the products is a new compound containing all the elements that reacted. Okay, so the opposite of a synthesis reaction is a decomposition reaction. That's where a compound will separate into two or more simpler substances. This is a reverse of a synthesis reaction. So you have compound AB is split into A plus B. So any synthesis reaction becomes a decomposition reaction when it is ran in the opposite direction. Now, when you have this, energy is released when it proceeds in one direction. So that same amount of energy must be added, all right, to have the reaction run in the opposite direction. Now, one example of a synthesis reaction is when we form water from hydrogen and oxygen. So there's our equation. 2 hydrogens plus 1 oxygen, 1 mole of oxygen, yields 2 moles of water. All right, so, and we will do this in class, we will decompose water and we'll break it down into the hydrogen gas and oxygen gas. So, and it takes energy to do it. This produces energy, this takes energy. This is the synthesis reaction. The same reaction ran in the opposite direction, but there is a key difference, all right? The synthesis takes a lot of energy. It'll take electricity. Right, or it'll when you light hydrogen and air, all right, to form the water vapor, it'll produce a flash, a bang. It's pretty cool, and we'll watch this video in class. So for the decomposition reaction to proceed, the same energy that was released in the synthesis reaction to make the water must be added back into the water to break it down. Now we'll put electricity into the water and we'll perform electrolysis, which is a method for decomposition of water. So this is how we can use hydrogen as fuel. Okay, first we've got to use electricity to decompose the water into hydrogen and oxygen. That is energy. Then you store the hydrogen in tanks for further use. The hydrogen is then used to synthesize water, and this releases energy that was initially used to decompose the water. All right. So the exhaust from a car, if we were using hydrogen fuel, would be just water vapor. So I know engineers and scientists are working on this because this would really help our energy crisis. So now we were talking about molecules with water, but we can also use synthesis and decomposition reactions that will happen with ions and ionic compounds. So here's a synthesis reaction for table salt. 2 moles of sodium plus 1 mole of chlorine gas will yield 2 moles of sodium chloride or salt. Now the decomposition reaction would be 2 moles of sodium chloride yields 2 moles of sodium metal plus chlorine gas. So this is another case where the synthesis releases a large amount of energy. And we'll watch this video in class also. So for the decomposition reaction to proceed, the same energy that was released in the synthesis reaction has to be put back into the salt to break it down. This is how we do it. All right. We first melt the crystal, then we electrolyze the molten salt into the ions. Okay. Now, by one well-accepted definition, there can only be one product from a synthesis reaction. However, we use that definition that there can be more than one product as long as one of those products is more complex than either reaction. So, 2 elements forming a binary compound is a synthesis reaction. But there's other types of synthesis where you can have more than one binary compound. So we'll look at some of those. So we're going to consider that a synthesis reaction when the reactants which are elements of binary compounds, react to form a ternary compound, which is a compound that has 3 or more, or 2 or 3 elements. So, y'all studied photosynthesis in biology. This is an example of a synthesis reaction that is not the cookie cutter A plus B yields AB. So we have 2 binary compounds, carbon dioxide and water, and the products are glucose and oxygen. So it's got 2 products, but glucose is a ternary compound, which has carbon, hydrogen, and oxygen. So a more complex product is created by the reaction, so we can consider this to be a synthesis reaction. Now, when we were talking about a single product synthesis, energy was released by the reaction and it needed to be returned in order to drive the decomposition reaction. Okay, this is almost always the case if you've only got one product. Now, a synthesis reaction which produces a single product will release energy. Decomposition reactions which break the product into its original species requires that the released energy be put back into the product. Now, the opposite occurs with photosynthesis. Now, we've got light energy is needed to drive this synthesis reaction. So, the needed energy is usually provided by the sun. That's why we've got the name photo and synthesis, meaning that it's a synthesis reaction made possible by light. So energy captured by this reaction is stored in glucose, C6H12O6. Now, most life on Earth relies on the energy captured by the glucose molecule, either directly or indirectly. Okay, in order to use that energy, okay, and glucose is C6H12O6, life has developed elaborate processes which we call respiration. And they have the net effect of driving the decomposition reaction, releasing the energy captured from the sun. So we've got glucose plus oxygen, and it's going to yield carbon dioxide and water. All right. So that solar energy that was captured by the photosynthesis reaction is released by the decomposition reaction when bodies and plants and living things use the glucose during respiration, and that's how they live. So anyway, guys, this is Coach Scott saying that's pretty good coverage of synthesis and decomposition reactions. All right, we'll go into our next one here shortly, and we'll have those videos ready. So anyway, this is Coach Scott saying bye for now.